so before we proceed further, let me first give you some idea about what we have just started with. So we talked about, this kind of pattern that we see. Okay, so um, every consecutive years or consecutive time period, there are certain changes. So how do we really explain these changes? Okay, so one way, so it is just a visual diagram. So I really don't know if there are, some sort of correlation between this period. I mean, if it is really the case that every consecutive years are actually going to see a sharp change, in the opposite direction. So what we do, we actually, you know, plot we actually plot certain, um, we can plot scatter plot here. Okay, so in scatter plot you can actually, uh, you can actually draw a scatter plot. All right. Say I want to plot the the first example where I had this rainfall in Los Angeles. Okay, where you have seen that the, show you the, yeah, the in the diagram you have seen that there is a possibility that every year the rainfall has significantly changed, okay, in the opposite direction. So whether that is the case, we can actually, uh, what you can do, you can just simply do a scatter plot. For example, in this example, the data set we have, if you just plot it, you will see something like, not a very prominently positive or negative trend. Like if I just use, say, on the y-axis, say, tth period, and in the x-axis I plot t minus 1th period. Okay, so what I see is I'll see no prominent trend here. So if, suppose if high and if the high is corresponded with a low, so it should be concentrated here on the top, right? If the high is corresponded with low, and if the low is corresponded with a high, I mean, what was our hypothesis? It should be corresponded. It should be concentrated here, but we don't see any of this. Okay, so this, we will say that this is not probably the case, and this is not happening. So, and this is also not a very good time series data because you can't see anything clearly. Whereas in the other case, say the next example that I said, where, just a second, the next example where we have said that, okay, so this was the diagram. So this was the plot that we made, where we have, where we're claiming that the first diagram, it doesn't have a very clear sort of negative or positive correspondence. Okay, so we'll provide this data and you can do it yourself. Whereas in the second diagram, just a second, in the second diagram, where we plot this chemical property, color property of the batches. So if we plot that, we actually will see that, let me go back to that. Yeah, we'll actually see that there is a, or the Canadian here for that example. Let me just do this one. The example of Canadian here. Okay, so this is a very, clearly sort of a positively correlated time series. So here you will see something like this. So some points are concentrated here. If the population is low, the next year population is also low. Then the population is high, next year population is also high. I'm sorry about this. And then you have in between points. Okay, so I'm not using really my pen here, so it is a little not so good looking curve, sorry, diagram, but yeah, you can still make a sense out of it. So this is 8th period, and this is my t minus 1th period. Okay. So this is one way to understand. The scatter plot is one way to understand if there is any relationship between two, consecutive periods. So there are other ways that we're going to see that. So one thing that I wanted to, okay, so let me actually show you the diagram. So here, the second diagram is actually representing the population of hair and across time and how they're related. Okay, T8 and T minus 1 period. All right. So now we talked about this concept of seasonality and trend and noise and level, right? So let me just draw something to actually explain what these all mean. So here, if I draw again, so let me just draw it small so that I can have it. Let me draw this, change this. So let me draw it here. So let me draw actually 4 different coordinates. So let us first have something like this. Okay. Oops. Something like this. This will do. Okay. So here you can see there is a very clearly there is a trend here. Okay, you can see this trend here. Okay. So I'll just separate out this trend. All right. Then you can see this periodicity here in this diagram, the first diagram. Diagram 1, diagram 2, this is our 3, diagram 3, and oops, the next one is diagram 4. Okay. So now once I get the trend, now I'm left with seasonality and my noise. So if I just take out the seasonality, so my seasonality would be something like this. Okay. Now if I take out both the trend and the seasonality, what I'll be left with is called my noise. Okay. So it will be something like this. This is my white noise. Okay. So the error term in time series is often called white noise. And white noise is a certain property we will see in other videos. Okay. So this is about the the basic introduction of time series data, and to sort of look at what are the different aspect of it, different components of time series data and all. Okay, one last thing before we end, that is when we use this, when we actually get this component out of time series, we use a method called a decomposition method. Now in decomposition method, what we have just done is called simply decomposition. So we have basically taken each element out from the time series. It could be additive decomposition, so where we have simply added these components. So basically, if we add, our component, in the diagram 2, diagram 3, and diagram 4, they will add up to diagram 1. Okay, and that is why it is called additive. Now the other model could be multiplicative, where you actually multiply, the trend and your seasonality and your noise. Okay, so 2, 3, 4, you just multiply, and then you get another time series data. So you can use both, or you can use the multiplicative model. You can take a log of the multiplicative model and you can get into additive model as well. Okay, so that is how you basically look at, basically decompose the whole time series data.